we've got more application problems today, so let's remind ourselves before the examples what the steps were for a word problem last time. Remember, we said to read and underline the important information. Then you're going to define your variable. Then you're going to write an equation. Remember, if it's an equation, it's got to have an equal sign. And you're writing the equation to represent the situation that the word problem's talking about. Once the equation sets up, and remember step 3, that's the hard part. Once the equation's set up, you're just going to solve for your variable. Okay, so that's kind of what we did last time with our steps. We've got 2 types of examples today. One's called the perimeter problem, and the other one's called the consecutive integer problem. Okay, steps and ideas are kind of still the same, so let's read it and underline. The width of a rectangular garden is. Okay, I'm going to underline width, and I'm going to circle the word is. So do what I do. The width is 5 feet less than its length. Okay, the perimeter, big word right there, is 38 feet. What is the width of the garden? Okay, so I'm trying to find the width of the garden. And on the perimeter problems, you guys, you're always going to use L for the length and W for the width. So let's write that in there. Find the width of the garden. All right. Now, on the perimeter problem, you can always write an equation from this first sentence here. So I'm going to write it like it reads. The width, W, we'll use a different color. The width is. You guys need to know that is represents equals when you see that in a sentence. So the width is, the width equals 5 feet less than the length. Less than subtraction, and remember that it goes backwards. Okay, so you have to like flip-flop the 2 things they're talking about. I'm going to use L for the length, and remember I use that little like cursive L so it doesn't look like a 1. And I put 5 at the end. Okay, so that's my sentence. The width is 5 feet less than the length. They're talking about a rectangular garden, you guys, so I would always draw a picture of the garden or the rectangle, whatever it is they're talking about. We know that on a rectangle, it's like length is the long side, width is the shorter side. Now, to find the perimeter, that's when you add up all the sides. Here's the problem. If I take my rectangle and add up all the sides, I'm going to have L plus W plus L plus W. I'm going to be using 2 different variables, which if you have 2 variables, you can never solve it. So here's where this first sentence, this equation, comes into play. We said the width is the same thing as the length minus 5. So let's come to the width right here. I'm not going to use W, I'm going to use L minus 5. Because we said that's what the width was, 5 less than the length. Okay, so now I'm going to add all 4 of those sides up, because I'm talking about the perimeter. So I'm going to do L minus 5 plus L, plus L minus 5 plus L. Okay, so I added up all 4 sides, and that equals the perimeter, which is 38. Now I have an equation that just uses L, so I can solve this. Let's see, I see 1, 2, 3, 4 L's. So I'm going to combine like terms. Right here, negative 5 and a negative 5 is a negative 10 equals 38. Okay, so now I'm just going to solve it like I always would. Add 10. 4L equals 48. And then I'm going to divide by 4. And I get L equals 12. You need to always make sure that you answer the question in a word problem, you guys. That's crucial. So like, come back to the question. They wanted to know what's the width of the garden. We have the length, not the width. So here's where you like bring it all the way back up. And I know it's kind of a lot of steps, but we said the width was the length minus 5. we know the length is 12, so if I do 12 minus 5, I get the width is 7. So that is my final answer. All right, a lot of steps, but it's repetition, you guys. It's the same thing every time, so let's do one more of these. I see the length of a, so I'm going to draw my picture right off the bat. And I'm going to write an equation from the first sentence. The length of a rectangle, so length is, that's L equals. The length is 2 feet more than twice the width. So more than's add, so 2 add to twice the width, that'd be 2W. Okay, the perimeter is 34 this time. What are the dimensions? If you see dimensions, realize that means length and width. They want me to find both of the dimensions, the length and the width. Okay, so let's come to our picture. Now, they said, and I don't want to use L's and W's, because I can't solve that if I use two variables here. So on my picture, my goal is to label with one variable. So the length is the same thing as 2 plus 2W. So instead of writing L, I'm going to put 2 plus 2W for the length. Okay, now I want to add up all four of these sides. So let's add W plus 2 plus 2W plus W plus 2 plus 2W. And that equals the perimeter, which is 34. Combine like terms, so W's I see 1 plus 2 more is 3 plus 1 more is 4, 5, 6. So I see 6 W's here. 2 and 2 is 4 equals 34. Now you just solve it, regular old two-step equation. Divide by 5 and divide by 6 and W would equal 5. Okay, so we have part of the answer. Remember dimensions, they wanted both. So I have part of the answer, but I'm going to bring that answer up, that's an arrow, to the original problem. And to get the length, I'm going to put 5 in right here for W. So 2 times 5 is 10, plus 2 more. The length would be 12. Okay. On the back here, this is called the consecutive integer problem. And same thing, you guys. The perimeter problem is the same idea every time. I know it's a lot of steps, but if you practice it enough, you'll get it down no problem. It's the same idea with consecutive integers. Same process every time. So first example says Mrs. Myers is thinking of 3 consecutive, so let's read it and underline, 3 consecutive integers. The sum of the 3 integers is 72. I want to find the integers. Okay, let's decipher what's going on here. There's 3 numbers we're talking about. Integers, that just means like no decimals pretty much. So positives and negatives, no decimals. Consecutive, you need to know what that means. It means in a row. Okay, so here's how I do this problem. I make up 3 numbers. So 3 numbers in a row. All right, let me just make up 2, 3, and 4. So I'm going to say make up an example. 2, 3, and 4. In algebra, you guys, when you don't know something, and obviously 2, 3, and 4 are not the 3 numbers that I'm thinking of here, but when you don't know something in algebra, you call it x. So I'm going to call the 2 x. Now, I can't say x, y, and z, because if I use more than one letter, I cannot solve it. So I need to call 3 something that uses x. So think about 2 and think adding. If you add 1 to 2, you get 3. So I'm going to call 3 x plus 1, because if you add 1 to x or 2, you get 3. Okay, I'm going to call 4 something that uses x. So if I come back, if I add 2 to 2, I get 4. So I'm going to call this x plus 2. Now, please be aware that I made up my example. So, I mean, hey, I could go like this and cross it off. It means nothing. This is what I care about, where the variable is. Now, sum, that means add. So if you add your 3 integers together right here, you should get 72. It is 72 equals 72. If I solve this, so I'm going to combine like terms, I see 3x's plus 3 equals 72. And if I subtract 3, and if I divide by 3, I get my answer. So x equals 23. Now, again, make sure you answer the question. They wanted you to find the integers. That means all 3. So if I came back up, x, the first one, is 23. If you add 1 to that, it's 24. If you add 2 to 23, it's 25. Can we be real with each other? You can check this problem. If you add the 3 numbers together, you should get the sum, 72. So I'm right. Okay, one more. The sum, which is adding, of 3, so it's 3 numbers again. 3 consecutive, okay, this word right here changes everything. 3 consecutive odd numbers is 285. I want to find the largest integer. Seriously small sentence, but a lot going on. I make up a problem so I can start this and figure this out. It's 3 odd numbers this time. So, okay, maybe I'm going to make up 3 odd numbers. Let's do 5, 7, and 9. You always call the first one x. This time you add 2 to 5 to get 7. So I'm going to call that x plus 2. And you add 4 to 5 to get 9. The last integer is x plus 4. I made up 5, 7, and 9. The sum, so if I add these together, I should get 285. Now let's combine like terms. That's 3x's plus 6 equals 285. Okay, so if you subtract all this and then divide, you should get a nice whole integer number, and you do. You get 93. Okay, so bring it back up, answer the question. They want the largest number. X, 93, is actually the smallest one. You have to add 2 to that to get the middle one, and you have to add 4 to that to get the biggest one. So the answer is 97.